Hi, welcome back, students. Today we are talking about the solar system. All right, so the solar system consists of the sun, our sun, and everything that orbits our sun. There are millions of suns and stars in the universe, but our solar system specifically is comprised of a single sun, 8 planets, a few moons that orbit those planets, a few dwarf planets, and then lots of other little small objects like asteroids, comets, and other icy beings. So if you're curious about our solar system, this is a great place to find out more information because we are going to talk about where we live. We're going to talk about what planet is known as a dwarf planet and was previously considered an entire planet on its own. What is the largest planet in our solar system, and how many planets are there in our solar system? So these are some kind of questions that you can write down in your notes, and as we answer them, you can kind of write down the answer next to them, and those would be great to refer to when you're taking exams or studying for those exams. All right, so the first thing that we need to talk about is that we are learning about astronomy. Okay, this is not astrology. Astrology is like saying I'm a Gemini or my husband's a Leo, but astronomy is the study of everything beyond Earth's atmosphere. So as you exit Earth and you start to enter space, any study of space beyond Earth's atmosphere is considered astronomy. Now, we've already talked about how everything that you study on Earth is geology, okay? So there is some geology that we study on other planets, but most of the time the studies out there are referred to as astronomy. Okay, so the universe comprises everything. So this is all matter, energy, and space. In our galaxy, we live in the Milky Way galaxy, and we are not unique. There are over 50 billion galaxies across the universe. So when people think that we're special, we're not. I'm so sorry. There are billions of us out there in the universe. All right, so the Big Bang Theory. This is how our universe began. In its simplest form, there was a small reaction between singular matter. So there was very, very simple matter that basically ran into each other, and it made this huge explosion, and everything started expanding from there. So this expansion is part of another theory called the expansion theory. And as we grow, we start to move further and further away from our central point in the universe. And so if you want to understand the Big Bang a little bit more clearly with some really interesting graphics, this is a great video. This will also be linked in your module to reference. And I won't play it here because it'll sound kind of funny through the recording, but you can reference this at any time. This is a great video for you. All right, so where is our solar system? So our solar system isn't even in the center of our own galaxy. Our galaxy isn't the center of the universe, so we're kind of off to the side. But in our Milky Way galaxy, our solar system is on the side. I think I have a picture and a couple slides here. So our solar system, like I said, is a very close. Sorry about that interruption. So our galaxy is the Milky Way galaxy, like I said, and our solar system, all of the stars that we see from Earth in our solar system are all part of our own galaxy. We don't see stars outside of our galaxy. They're too far away to see. So that's kind of an interesting fact. Okay, so here is a look at our Milky Way galaxy here. This is a barred spiral galaxy. So it's not a circle. It's kind of like a bar linear piece that then orbits in a circular pattern. And then before we knew a lot about our own solar system, we thought that the Earth was the center of our solar system and the universe and our galaxy. So that's called the geocentric model. But we know today that we are not the center of the solar system or the galaxy or the universe. We are actually off to the side a little bit. So here's a look at an artist rendition of our solar system, our galaxy. And so this is the center of our galaxy, and our sun is here off to the left in this image. So we are about 100,000 to 120,000 light years in diameter in our Milky Way galaxy, with over 200 to 600 billion stars. And that's just our single galaxy. Remember, there's billions of these in the universe. So we think that there's about 50 billion planets, and 500 million of which could be within their habitable zone for life. So habitable zone means that they are within a good range where life could be sustained, which is where Earth sits for our sun. So if we go to some of these other solar systems, we might be able to actually see Earth-like planets. Whether there's life on them or not, we have no idea. But there are people that are constantly searching for that and deciding whether we can actually make it to any of these things. But as it stands, we haven't even sent anybody to Mars yet, which is, I think, in the future plans for NASA. But since we haven't actually successfully sent anybody to Mars, which is in our own solar system, it's highly unlikely that we're going to make it there very soon. All right, so the age of our solar system is around the same age as Earth, which is 4.5 to 4.6 billion years old. That's our best estimate. No, it's not. Hold on. I'm so sorry. It is. I was thinking of our galaxy. Our galaxy is 13 billion years old, but our solar system is the same age as our Earth because it all formed around the same time, more or less. So we are a collection of objects that orbit a single star or our sun, and we consist of planets, moons, asteroids, comets, dwarf planets, and Pluto, which is now a dwarf planet, but used to be a full planet on its own until 2006. And we'll talk about that in a second. The mass of our solar system is about 99.86% made up by the sun. So the sun is most of our mass in the solar system. And then our planets are very heavy, so they make up the other smaller percentage of our mass in our solar system. All right, so here's a look at our solar system planets. So we know that we live on Earth here. It's the third planet from the sun, right? So we have Mercury, that's closest to the sun, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then Pluto's on here for fun, but it's not technically a planet anymore. But it is one of the larger other masses that's not considered a planet in our solar system. So if you have any kind of time outside of this to discuss with members of your family or friends, this is a great activity to talk about what our role is in the solar system. What does it mean to be one single person in our solar system? You can discuss that. We will discuss some other things about whether we should be looking for life outside of our planet in our discussion post this week on Canvas. But this is a good kind of probing question if you ever want to discuss this with family or friends, or maybe you want to talk to a random person about it because you don't want to talk about the weather anymore. Start asking them deep questions like this. What do you think it means to be a single person in our entire solar system? They probably stopped talking to you, but it's something to discuss, and it's a really interesting topic. All right, so we're going to start looking at the planets more in depth here. So these are our inner four planets. We call them terrestrial planets. These are Mercury, Venus, Earth, and Mars. And they all have different orbital periods because they all move, as you move away from the sun, a little bit further from the sun. So it takes longer for them to orbit. Okay, so for an Earth year, it only takes Mercury 88 days of our Earth year to orbit the sun. So their technical year is a lot shorter than ours. Venus is very particular, and it's the hottest planet in our solar system. Although most people think that Mercury is, Venus has a very thick cloud layer that keeps it really, really warm. Earth is the only planet that has the correct atmosphere and water available for life, and we only have one moon. And then Mars is our red planet. It has very large dust storms, and it has the largest volcano in our solar system on it. So we'll talk about them individually really quick. So here's Mercury. Like I said, it is the smallest and closest to the sun with the shortest orbital period. Orbital period is how long it takes for one rotation around the sun. Okay, it was named after the swift messenger of the gods by the Greeks. So it was found pretty early on when we started looking at the night sky. Temperatures on Mercury range from about 473 degrees Celsius on the side that faces the sun and negative 173 degrees Celsius on the dark side. So that's the side that faces the rest of the planets, essentially, and it never actually faces the sun. Because it's so small and it's so close to the sun, it does not have an atmosphere at all. So there's no cloud coverage, so you can see its surface through a telescope, a high-powered telescope anyway, pretty well. And it rotates 3 times during its 2 rotations around the sun. All right, then we go into Venus. Venus is the closest planet to Earth. It is the 3rd brightest object in the sky, and because of its brightness, it was named after the goddess of beauty, Venus. The surface of Venus cannot be seen, so unlike Mercury, you can't see the surface because there's so much atmosphere, so there's thick, dense clouds that cover the planet, keeps it really hot. I actually don't have the temperature listed here, but it's very hot. But the surface rocks that we do see are probably volcanic, so we are thinking that it has a lot of volcanism on the surface, but there's only very limited viewpoints to actually see the rocks on the surface. And then Earth, we're going to spend the rest of the semester learning about, but for now, it is the 3rd planet from the sun. It is our largest of the terrestrial planets. It's the 5th largest planet in our solar system, so the other 4 are much larger. It's the only planet with life, as we know. We have 365 days to spin around the sun, and we have a single moon. Then moving on to Mars. So Mars is our red planet, right? The surface of Mars has really cool features, those being volcanoes, a really, really large fracture, which you can kind of see in this image here, which is similar to our Grand Canyon. And they also have polar ice caps. You can kind of see that at the top there of the planet image. And those ice caps actually contain CO2. So we don't think that it is H2O, but there is some evidence that there may have been frozen water at some point because we have pulled some samples, and those samples have very small traces of water vapor in them. So really interesting. And Mars is actually one of the busiest planets outside of Earth because it's most visited for exploration. So when we're looking for other life or past life that may have been in the solar system previous to Earth, we are looking at Mars most of the time. There's a few other moons that people are starting to investigate that orbit Jupiter, but we haven't got there yet. So right now we have a huge focus on Mars, and Mars has a lot of rovers that go to it and investigate it. And one of the biggest ones was about 10 years ago. Oh my gosh, it's been 10 years now since Curiosity was there. Well, it's still there. It doesn't come back. But Curiosity discovered that there was 2% water in the soil that it picked up. So this rover actually was one of the most advanced that we had sent at that point. And it collected soil, and in its contraptions has a oven, and they heated up that soil. They weighed the soil first, then heated it up, and they saw that there was a difference in weight. That difference in weight in general, when we do that on Earth, is water that evaporated during the drying process. And so they calculated about a 2% difference, and that is really good news because that means that there could have been water on this planet at some point. In what capacity and whether it would sustain life, we still don't know that. But we still send things to Mars all the time. And like I said, I believe there's future plans to send people, but I believe they're one-way trips. So you would live the rest of your life on Mars if you made it. So if you want to learn a little bit more about one of the most recent, it's 3 years old now at this point, cool rovers that went to Mars, this is Perseverance. This went in 2020, so you can watch this neat video of the rover there. And then here's a look at the topography. So we haven't learned about maps of topography yet, but this shows you the highs and the lows on the planet. And this is really interesting to look at because you can see the real deep crevasse, which is the Valles Marineris, which is one of the largest, basically, cracks in a planet that we've observed. And we also have Olympus Mons, which is a volcano, and it's the largest volcano in our solar system. So let's take a look. So here is Olympus Mons in satellite, kind of like a satellite imagery. It's from a telescope. And so this is much larger than our Mauna Loa volcano, and Mauna Loa is one of the Hawaiian volcanoes. And Mauna Loa and Mauna Kea are the largest two volcanoes on Earth as far as their volume. And this one is about 3 times the size of Mauna Loa. So it is very large. So this is 24 kilometers in height, whereas Mauna Loa is only 9 kilometers from the ocean floor. So very significant difference there. Huge volcano. Then we get over to the Big Canyon, the crevasse that I was talking about. This is about 4,000 kilometers in length and 6 kilometers deep. It's pretty visible, as you can see. They think because we don't have any hard record of large amounts of flowing water on this planet yet, that this was from crustal fracture and things shrinking as it cools down. So our Grand Canyon is formed from water, whereas this one we're thinking may be formed from more of a crustal shrinking and things cracking. All right, so moving into the Jovian planets. These are our outer 4, so these are past the asteroid belt between our terrestrial planets. So we have the sun, the terrestrial planets, the asteroid belt, and then our Jovian planets. The Jovian planets are the furthest 4 planets from our sun. So Jupiter is the largest. It's the first one after the asteroid belt. And one day in Jupiter is 9 hours and 55 minutes. It has a very short day, which is very unique. Saturn is famous for its ring system, although it's not the only planet with rings. It often gets kind of put out there as the only one. And then we have Uranus, which is a very cold planet. It's negative 224 degrees Celsius. And then we have Neptune out there just past Uranus, and it is the ice giant. All right, so looking at Jupiter first, like I said, it's the largest planet in our solar system in both volume and its total mass. We named it after the Roman god of heaven because of its brightness and giant size. The really interesting thing here, other than its gigantic size, is that it has a storm system that is hundreds of years old. And the reason that we know that it is hundreds of years old is because it's been there since we started observing it in the night sky. So it's a very old, long-lasting storm system from what we can tell. And it is covered in a thin layer of clouds with hydrogen, helium, methane, ammonia, and some other substances. It has 79 total moons. 4 of them are major, much larger moons: Callisto, Europa, Io, and Ganymede. And the density is very low, 1.3 grams per centimeter cube. So that's very light. The density of granite is about 2.5. About less than half. All right, so here is the giant red spot, or the hurricane-like storm that has lasted hundreds of years. We've got some pretty good images of it historically, and there's constantly people interested in trying to figure out why the storm lasts, or if it really is a storm. It looks like a hurricane-type storm, which is why it's been deemed that for now. But hopefully in the future we have more answers. But as of right now, It's a really cool feature that only Jupiter displays. All right, then we get into Saturn. Saturn has the distinct rings, right? Everybody knows Saturn for its rings, and it also has a really interesting incline. So the rings are inclined to 270 degrees to the orbital plane, so it's not in line with the way that it orbits. The rings are thought to be ice and ice-coated rocks. They can be micrometers in size to up to 10 meters, so pretty large range of size here. The diameter is 9 times Earth's, so it's 95 times more massive than Earth. So, but the density is even lower than Jupiter. It's 0.7 grams per centimeters cubed, and it has 82 moons. So there's a lot of things, because these planets are so big out there in the Jovian section, that there's a lot of little small bodies that ended up rotating around these larger planets. So they have a lot of moons. All right, then we have Uranus, which was discovered pretty late in the 1700s, and it was named after the father of the Titans and the grandfather of Jupiter. It also has a ring system, but it's a much smaller particle size. And the density is around the same as Jupiter's. And it also has a bunch of moons, 27 moons. So this one is also interesting because it rotates on its side. So instead of rotating kind of up and down like the other planets, it rotates on its axis, on its side. So, fun fact, you can't stand on Uranus. You might be in for a bit of a shock when you step off a spaceship. That's because Jupiter, Saturn, Uranus, Neptune don't have solid surfaces. And so they are mostly made up of hydrogen and helium. So they are gas giants. So our Jovian planets are considered gas giants, which is why they're so far out from the sun. So with gravity, most of the mass of the solar system is at the sun. So all the heavy stuff is going to get closer to the center near the sun, and then everything else that's lighter goes out, which is why these have low density as well. So they're all made up of gas. All right, and then we have Neptune, which was discovered in 1846, just after, a few years after we discovered Uranus, and it was kind of discovered by accident because they were looking at Uranus and noticed some weird motion it was making that looked like something else was pulling on the orbit of Uranus, and that happened to be Neptune. And so they started to do more investigations on Neptune and found that it was its own planet. And not only was it its own planet, it also had a spot similar to Jupiter's, but it's blue. So instead of a big red spot, a red hurricane, it looks like a blue hurricane. But it's much smaller in size, and it's very similar to Uranus. So a lot of times they're considered twins. Neptune has 14 moons, and it doesn't have a lot of studies because it's pretty far out there. I think they got some images when they sent that satellite to Pluto to capture some images. But it's really hard to get to because it's so far out in our solar system. So, if you are a new college student, you probably were not old enough to really realize what was happening. But in 2006, which is when I was in high school, after learning through my whole school that Pluto was a planet, they decided it wasn't a planet. And we had to shift from it being 9 planets to 8. And so now kids just learn that it's 8 planets and then Pluto's a dwarf planet. But there wasn't a very good solid description for what constitutes something being a planet and not just some other celestial body until 2006, where the International Astronomical Union got together and decided on 3 criteria. So one being it must orbit the sun, so Pluto orbits the sun. It must have significant mass for self-gravity, so Pluto has enough gravity to be a cylindrical object. It's a round shape, right? And then 3, it has to be the dominant body within its orbit. So that last one disqualifies Pluto as a planet. So I will show you its orbit. So this is Pluto's orbit, that pink. And there are 2 spots where it crosses into Neptune's orbit. And that means that it lies in another orbit at some point, and Neptune's much larger than Pluto. So it's not a planet. It is a dwarf planet, along with these other 4. So we have 5 dwarf planets in our solar system. Not very many of them get mentioned because Pluto is, I would say, significantly larger than the other 4, but they're still there. So they are kind of important, but they don't, not all of them orbit the sun. Not all of them are very round. So they kind of find themselves in this dwarf planet, but they're not exactly like an asteroid or something that's just kind of floating around. So during that 2006 Astronomical Union meeting, they also kind of made some criteria for what would be like a dwarf planet instead of just a celestial body or an asteroid or something like that. All right, so this is a game that you can do to kind of practice where you want the order of the planets. I will quiz you on this throughout the semester on exams and quizzes. So trying to order the planets, and here would be your answers. You can play this on the slideshow on your own if you would like to practice. You can also, a good way to practice the order of the planets if you don't know them, you can draw them out. So start with the sun and then see what you can do from there, and then just kind of practice that. The biggest thing is knowing which 4 are inner 4 and which 4 are outer 4 and why that is. So the inner 4 are rocky planets and the outer 4 are gas giants. All right, so let's look at some moons. So our moon is on its own, so we only have the one moon. We landed on the moon in 1969, so if you're on conspiracy TikTok or something, maybe you don't think this, but for science sake, we landed on the moon in 1969. The first word ever said from the moon was Houston. They were going down to the receiving station on Earth. There were reflectors placed on Earth so that we can measure how far or what the distance is from Earth to the moon. So those reflectors on the moon help us measure. So we send a beam of light. That beam of light bounces back, and we can measure based off how long it takes to come back, how far we are from the moon, which helps us tell things like what is our gravity looking like? Are there changes in the Earth's tilt? If we're getting further away, maybe the expansion is happening faster than we thought, all of those kinds of things. But we're about 240,000 miles from our moon. All right, so it is the second brightest object in the sky. Venus is the first. There is no known origin of where moon came from, and all of the other moons in the solar system are named something. It's just ours that is not named anything particular. It's just the moon. And our month is based off of the moon's cycle, so how long it takes to orbit the Earth, so it does orbit us. And it takes about 29.5 lunar days, which is why some of our months are 28 days and all the way up to 31. So it depends on how long it takes the moon to orbit the Earth. And as it moves further away, the longer it's going to take. All right, so the origin of the moon. This is primarily from the Great Impact Theory. So there was a large object that was maybe a quarter the size of Earth, about the size of Mars, that struck Earth. And Earth was a little bit stronger than it, and all of those pieces kind of went out into space and then recollected themselves and started orbiting Earth because of its gravity. So all of that material ended up kind of coalescing and formed the moon, and this is probably happened around 4.4 billion years ago. That's based off of data that we have from the moon samples. All right, so one of the biggest things that you probably learned in school was about moon phases, right? So as the moon orbits Earth, it goes through different phases. So there's a couple of different ones that we refer to. So we have waxing phase, which is when the illuminated portion is getting larger. So the part that is lit up is getting more and more area. And then the waning phase is when that portion is getting smaller. Okay, when we're looking at a crescent moon, that's less than half of the visible portion is illuminated. So remember, the moon only faces one side. One side of it faces Earth. We don't see the dark side of the moon, right? So when we see less than half, we're looking at a crescent moon. If we see more than half of that portion, we see a gibbous moon. Okay, so if we look at the phases here, we start with a full moon, right? And then we go through the different phases, okay? So a good video and kind of imagery to get an idea of how this works is in this video here. This video is a very good demonstration. You could also recreate this if you wanted to, but it shows you the illuminated portion and what you would see as, so the light is the sun, what she's holding is the moon, and she is the Earth. And so as you move around and you see the different illuminated portions, you can see the different phases of the moon. So it's a very good demonstration that I recommend you watch. Okay, and then last little bit here, we have the eclipses. So we have solar eclipses, and during a solar eclipse is when the moon blocks some or all of the sun's rays. Okay, so these don't happen all the time, but people get really excited when they do. The only thing that I will tell you is you do not want to look at this directly because it can hurt your eyes. So when there is one, I recommend you're looking through a very nice high-powered telescope that is for something like this. Or maybe you just take a picture and then look at it. Another thing that we've done before is we use a piece of paper to try to reflect it. It looks really cool, but like I said, try not to look directly at it, just like you don't want to look directly at the sun all the time. So this is, like I said, when the moon is blocking some of it, so it depends on where the moon is in its orbit and how close it is to Earth, whether we're going to see a full or a partial eclipse. And so what you can see in this image on the left here is what we call a solar corona, which is during a total eclipse. It looks kind of like, I don't know, little flares on the outer edge of the moon. So that's really cool to see. Like I said, make sure you're seeing it safely with the correct either glasses or telescope or whatever. And then when we don't have a full eclipse, you'll see what we call an umbra, which is a moon's shadow when it does not reach all the way to the Earth. Okay, so this is really an interesting phenomenon. It only happens every once in a while, but there is, I believe, a calendar that you can find online that'll tell you when these are predicted to occur. All right, so what I would do to kind of wrap up the presentation or the lecture for you is I would write down some of your impressions of the planets, the solar system, the galaxy, maybe kind of do a brain dump and see what you remember that you can put down on a piece of paper. And that way, when you go back to refer to your notes, you kind of regurgitated the material a little bit. All right, so there's lots of stuff that we can still learn. We are still learning. We're still exploring things. We're still sending rovers to Mars. We're sending satellites to take more pictures. We're planning trips to try to get people to Mars, all of those good things. So the more and more we explore, the more we're going to learn, and the longer this presentation is going to be. But in reality, we want to know what's going to happen next, what our universe looks like. If we know more about what our universe looks like, we can try to decide if we want to explore further or how it's going to impact us in the future. And then there are some additional resources for you that are links. These links will be on the slideshow for you. And then just to wrap up really quick, make sure your assignments are getting done. So we have the scientific method lecture, which you probably watched before this, the solar system lecture, which is this one, your lab, and then your solar system discussion posts. Okay? I will see you guys in the next lecture. Bye.